today, Thursday, January 23rd, 2020, and this is the second video for the 4100 board. On the first video, we gone over the setup for a full-way rectifier operating in open loop, and now what we're going to do is we're going to control or load. In this particular case, it's just a resistive load, but we're going to be looking at test point 4, the zero cross signal. That's position test point 4 on the board. Test point 6, which is the delay angle and corresponding to that zero cross did before, and the output across the load. So the first thing we're going to do is we're going to apply, on this particular case, control input power. It happens to be a 120. We have a 120 240, and we're only going between positions 3 and 5. So we're applying 120 to get 24 volts AC on the secondary, which is rectified to 30, and then it's fed into a voltage regulator to get 12 volts. Once the board is on, notice that we have the red LED and we have the power. Even if the board is inhibited, keep in mind that we have a low signal inhibit, and the red LED won't go off even when the board's enabled if that CKI is not above approximately half a volt. So can we enable, Tony? Oh, that's right. Got to apply the line in this particular case, 240 single phase. All right, and there it is. We have an input, yet we don't have an output because we're inhibited, and CKI is at 0. So right now, are you enabled now?
Yeah. Just take it to half.
Enable, now get it clear. That half a volt. There you go. Now it's cleared. Was a little less than half a volt. Now it's cleared. And now we have control on the SCR, and we can follow this. I'm going to actually make this coincide. Alright, Tony, you want to go ahead and increase CKI? And we can see how the falling edge of test point 6 follows the firing angle. And then I'm going to move this back again. And do you want to go ahead and come back, Tony? So there again, we are coming down on the output. And here we can see that we have an output that it's going to be minimum at 0 when CKI is below half a volt. You want to come just to half a volt, Tony, to see what happens when we really get there. We're starting at 23, approximately 23, and then go all the way, Tony, please. And then we get to go to 90% of 240, which would be about 212 volts DC. Now, if we wanted to make this output range less than 212 or even less than the 23 volts that we started, we're going to send you also a video that shows how to adjust the span and the bias to get the minimum output and the maximum output, or anywhere in between. The last thing that we're going to do is we're going to inhibit the board. You inhibit, Tony. Can you show me the instant inhibit? That's 4 and 6, right, Tony? Mm-hmm. Okay, go ahead. Enable, please. And now soft inhibit and soft enable. We notice that when we soft enable, the delay angle changes. It goes back and forth as in a particular time interval. But when we instantly inhibit, the delay angle stays. The load just comes in and out. The very last thing that we're going to do is now we're going to inhibit. We're going to turn the 240 across the SCRs. And one of the requirements, as I said, is to have the control input power in phase. Now we are going to show what happens when you don't have the 240 feeding the transformer out of phase. Alright, give me the 240 tones. Go ahead. I guess I put it in there.
You put it back. No, see,
okay,
I'm full on.
Right, there it is. So there's no control.
Yeah.
I mean, apparently you're changing that, but you're not getting any output. Yeah. All right. Go ahead, Tony, and go ahead and change this back. Yeah, go ahead and inhibit. I want to kill the 240. Turn this. I'm gonna bring it back again. All right. And the very last thing that I'm going to do is, Tony, can you inhibit the board, please? Can you kill the 240? And I'm going to remove J1. All right. Go ahead and bring in the 240, please. And go ahead and enable. And we notice there that although the delay angle is changing, we basically don't have any output, although the SCR it's attempting to fire. So this is the end of this video.